So another video on graphing linear functions. So we'll look at 5 different parts to this and try and combine the types of things that can be asked in exams rather than just focusing on one particular thing at a time. So we could set up the box like the long way, but let's do this the quick way again. Let's get the endpoints here at -3 and +3. So in this function f of x, I'll just come down the bottom here. We're looking for f of -3, which is going to be -3 plus 3, which is going to be 0. So my point is -3, 0. And f of 3 is equal to, you can see, I'll just write the line, it's going to be 3 plus 3. So you should be able to see this in your heads and just write f of 3 is equal to 6. So 3 gives me 6. Now, before I draw this, I'm going to look at the red one and just find out what values there are there. Because if we have two functions, let's just look at the two answers and then think about scale before we put anything on this diagram that we're going to be given here with no numbers on it. So graph the function g of x minus 3x plus 4 in the domain -1 all the way up to 2. So let's take the endpoints of the red function g of x. So let's look at f of -1. So we're looking at -3 by -1, which is +3, plus 4, which is going to give 7. And this is perfectly fine to write it down like this. You don't have to show all the maths. You are showing the maths by doing this. And then f of 2 is -3 by 2 minus 6. Sorry, I said plus 7 the last time. Plus 4. No, 7. So f of 2 minus 6 plus 4 is going to be -2. So we have my points -1 gives me 7. And when x is 2, I get -2. So the highest values and the lowest values is what's concerning me here. I have to go up to 7 on the y, that's my highest y value. And on the x, I just have to go to 3, which is the max value of the domains. And I got to go to -3. So if I have to go up to 7, and it doesn't look like I have 14 boxes, I have to make each one of them 1. That's the first thing we're deciding here. 1, 2, 3, 4, 5, 6, 7. I'll just put it in here because the point is going to be -1, bang on here, because we're going to call this one -1. Although on the x-axis, let me actually just change it. Let me move these in a bit closer. What I'm going to do is I'm just going to put the 7 in and I'm going to put the -1 in, but you can see the scale here on the x-axis is going to be double that of the y-axis, so we just have to keep consistent on both sides of the x-axis. So put your 1, 2, and 3 in, and your -1, -2, -3 in. Because if we're asked to find a point of intersection, which we are, it's definitely better to have bigger scale at some point. We couldn't do it on the y-axis. So let's look at our red points here. -1 and 7 and 2, -2. So -1, 7 and 2, -2. So I still, be careful, I got to come down on 1s here. So I got my -2. So 2, -2. So we don't have to put all the values in on the y-axis. So that's my red. So let me connect these two dots. You're going to put a ruler to them. Let me try and do a freehand. And then we are looking at my blue dots, which are going to be these two, -3, 0 and 3, 6. So just below the 7 is going to be my 6. Put my 6 in. And you can see here that the values at -3 and 3 are my domains, -3 to 3, and the same for my -1 to 2, that my dots are on or above those lines. So let me connect these, approximately there. So that's what we have. Look at what we're asked next, the point of intersection. So we just let the two functions equal each other. Now what does it look like in our graph? It looks like it's a tiny bit past 0. Not sure how much here, because you can see here how bigger scale would definitely help us here. And it looks just past 3. So just past 0 and just past 3. So we have to say x plus 3, this function, where is that equal to this function? Where is x plus 3, f of x, equal to g of x minus 3x plus 4? You can see they can make the question sound complicated. Bring the -3x to the left and add it to x to get 4x. We have a 4 on the right, bring the 3 over and take it away, and we get 1. So x is going to be 1 over 4, which is correlates to what we set up here. This is 1 over 4. And if x is 1 over 4, the first function we just added to 3. Y is going to be 3 and 1 over 4, or 3.25 if you want to decimalize them, you can. So my point 0.25, 3.25 is my point of intersection here, which you can see corresponds to the diagram that hopefully you've drawn very accurately. Find the slopes of the lines. Now I'm just introducing this here because we can actually find these angles here between these lines by finding the slopes. You won't be doing it at junior cert, but just to introduce that the angles of the lines are really important to be able to get. So from our previous knowledge, if we can write any equation in the form y is equal to mx plus c, the slope will be the number in front of x. My first function, f of x, we can change f of x to y, and we can see it's equal to x plus 3. So the slope of the blue line is whatever number is in front of x, and I've just put the 1 in. The slope is 1. And the slope of the red line, g of x, we'll call it y. Y is equal to minus 3x plus 4. And you can see the slope is negative, which corresponds to our diagram. M is equal to minus 3. So just keep this in mind going forward, that the slopes between lines when we're doing points of intersection will tell us what the angles are. And that's the end of this video. So take this into your copy. No harm if you really want to be a top student. Make up 2 functions yourself. Make one a negative slope and one a positive slope so they intersect somewhere close to the origin of this x and y axis, and set up your own question.